Welcome to episode 16 of the DevDecoder podcast. And with me today, I have my amazing host. I mean, she really is something to behold, really, isn't she? At the best of times.
know.
Yeah, I didn't mean it as a compliment.
Oh.
Rebecca, how are you feeling today, Rebecca?
Pretty good.
Why are you feeling so good?
Because you've not been in all day.
That's probably it. I'm feeling pretty excited today.
Is it because of Apple?
I mean, to be fair, I have been having a few problems with my iPhone recently. I've not been able to get it to sync, but I changed its name to Titanic and it's fine now.
That's mean. It's still too soon.
It's 19 weeks.
It was on 2 weeks ago.
The film was. We're literally over 100 years ago.
It's too soon.
Okay. Do you know what I was doing last night?
I don't want to know.
Well, interestingly enough, I was watching the Apple Developer Conference 2018 till late last night.
You live a good life.
I do. It's quite exciting. They had a new iWatch.
I saw. I bet you're going to get that one, aren't you? You love your Apple Watch.
Pre-orders open tomorrow. So I think I shall be splurging on a new iWatch Series 4.
Okay.
Do you know why? It has an ECG built in, so you can literally just like touch the crown and go, show me my ECG, and it's FDA approved, so that's pretty powerful.
Yeah, but you don't use it.
I use my iWatch all the time.
About 3 episodes ago, you admitted you do not use your watch.
No, I did. I said I don't use the cellular thing as much as I thought I might. Although I have actually used it a couple of times since then, so I'm starting to use it a little bit more frequently. Yep, and of course the new iPhone XS.
Yeah, expensive.
Yes, yeah, excessive.
Expensive.
Yeah, it is quite expensive. I don't think it's a lot more than the iPhone X was actually. I think it's a little bit more. The iPhone X was about £1,000 as well, so it's about the same. It's a bit more than that. It does look like I've always felt that the S series they always put an S on the intermediate. They kind of do one generation and put S. I always think the S series are better because they've kind of nailed it a bit. They've figured out what they're doing in the first version, and in the second version it's just better.
But they did. I don't know if it was a 5S or a 6S, and it literally just looked like. I can't remember what it was called. Maybe it was an iPhone 4.
They're always the same kind of form factor, aren't they? Or this time,
and then
it
was chunky.
Yeah. And
it literally just looked like like an iPhone 4 or something. I can't remember. Mum sent it back.
Yeah.
She was like, I don't like it. It's ugly.
Well, actually, joking aside, though, I mean, Apple has largely prided itself on its sales. Largely managed to charge premium by having good-looking devices. So devices people want to be seen with. I've never been particularly bothered about that side of it. I'm more interested in the ecosystem to an extent. For me, I actually really like the Android phones, and I've always been a big fan of them, but I found myself constantly hacking them and constantly playing with them to the point they stopped being good phones. So you get to the stage where I'd jailbreak them and do all the other kind of stuff, and then somebody would make a phone call and it wouldn't pick up because it was just so badly messed
Androids
up.
have got rubbish emojis.
Yeah,
if they updated their emojis, I'd be down for that. But
I think for me as well now, Apple does a kind of a very good job of tying people into its ecosystem. I'm not sure that's the way I'd much prefer the open source stuff. I don't use Apple's in my work. I largely use Microsoft stuff these days, and Microsoft's done a lot better job now of engaging with the open source community, and I think it's a much better environment to work on. But for phones and for watches and things like that, they're not always the leading edge. They like to pretend they are, but actually in many cases, other companies have kind of done something a bit more innovative. But Apple tends to be the first one to make something mass marketable to the point where it's stable, robust, and actually just does what it says. Although I have felt in the last 5 or 6 years since Jobs that they're sometimes a little bit less reliable than they were under him, and sometimes certainly the iOS updates can be a little bit...
The what?
iOS.
What's that?
The operating system.
Do you mean iOS?
iOS, yeah.
iOS.
So anyway, that's what's going on with Apple.
And they're raking the prices up, as per usual.
Yeah, and I wonder how much that's got to do with Brexit. And I wonder, there's certainly an element of the exchange rates have changed quite a bit. So sourcing materials. Also, the trade wars going on in the US at the moment. Who knows? But the reality is that Apple are raking in the profits, aren't they? So they could afford to make them a bit cheaper. But obviously, they're not doing.
Rebecca's Back to the Podcast. So you know flamingos?
Uh-huh.
They actually bend the legs at the ankle and not the knee. What? They do.
I believe you.
All week to find a fact.
What is wrong with that?
Absolutely.
Flamingos are cool. Do you know flamingos are actually not pink? They're only pink because they eat shrimp. I actually already knew that one.
You know, I think we should perhaps ask our listeners if we should fire you. I mean, if we...
What's wrong with the fact you're learning something new?
Actually, I knew that one, but
No, you didn't.
I did.
You didn't.
Well, we went to see flamingos at the zoo, and that was one of the things that they said about them.
There was
one
two
in
facts.
There was one in the States.
No,
where
I
saw
mean,
them.
which fact?
Both of those facts I knew. It had
All
like
right,
a
I've got
list of
another
facts
one.
about flamingos.
Got another one.
Yeah.
Sloths. Sloths can hold their breath longer than dolphins can.
That's because they don't move. I mean, they're like so inactive,
They
whereas
do
dolphins are like having to expend a lot of energy.
How do you
swimming.
know?
Well, they have to swim.
Yeah, sloths have to move.
They falling due to gravity is not the same as moving actively under your own power.
They can hold their breaths for a long time.
They're so lazy that they can't even bother grabbing onto a branch when they're going to die. Hi Jack, welcome back.
Hi Craig. Today we're going to carry on with the programming paradigms that we spoke about
Yes.
last week and not many weeks ago.
Yeah.
Went through the first two, which are procedural.
Sequential and structural would be the first two.
Yeah, sequential is orders.
The order matters.
Yeah.
It's instruction after instruction after instruction after instruction.
Mm-hmm.
And if you change the order, you'll get different results or things won't work.
Yep.
And then we did structural, which was loops, so allows us to jump back and forward, but also allows us to do conditional branching, and that means if then else kind of thing. So if this thing, then do this, otherwise do this other thing.
Yeah.
Which is actually one of the most core parts of any programming. So we use a lot of conditional branches. That also leads us to things like switch statements, which is for our less programmer listeners, that's an example of where you say, look at this particular variable and here are all the different things it could be and all the different things you should do depending on what it is.
Yeah.
So that's like an if then else, except for it's actually really like a if then, else if this, else if this, else if this, else if this, else do this.
Is there any actual difference between that in terms of the compiled code?
Actually, in terms of, you can boil them all down to just a conditional branch, and I'll leave that for an exercise for our programmer listeners to think, how do you write a switch statement or if then else statement using just a conditional branch?
Yeah.
That's all you've got. So the only thing you can do is say jump if true.
Yeah.
That's the only thing you can do. How can you then implement those kind of structures? And the same for while loops and for loops and repeat until loops and all the other kinds. Obviously, go-tos are trivial. All of those only require you to have a conditional branching.
They can all be boiled down, like you said, to just be do this if true, else do this.
Now that is a simplification. In terms of switch statements, the compilers are quite smart, and so they will just do them as a bunch of if, then, else, ifs, else, ifs, until a certain point, at which point they'll start doing what's called a hash table, which is a quick form of looking up and jumping.
It doesn't have to go through if.
Yeah,
every if statement,
yeah,
it knows.
It can basically look up where to jump to from using what's called a hashing hash table, which is think of it like for our listeners, an easy way to think of this is, imagine you have a library, and on the library you put the shelves, and you say in the shelves, let's just use the first letter of the title, and you have an A shelf, a B shelf, a C shelf, and a D shelf. It's now much quicker to find 101 Dalmatians, isn't it? Because you can just go look at one.
Yeah.
So you look at the O shelf, and if you want to find Spartacus, you go look at the S shelf, and so you can more quickly find something in a large set of
It's just
options.
grouping all the values so that you can easily narrow it down.
That's a simplification. Hashing is where we basically take the whole title and boil it down to a single number, and that makes it even quicker to find. So we can use structures like that. But in principle, you can boil a switch statement down to just if then else if, then do this. So the next thing is procedural programming, as you mentioned. And procedural programming is the first time we really start, programs are getting bigger and bigger at this point in the history of computing.
It's not just a simple set of instructions for the machine.
And we find we keep doing the same things over and over again in different places and having to rewrite all that code out.
Yeah.
So what we do is we create a subroutine, and that was the first.
Was it called a subroutine from the start?
Yeah, and subroutines were the first idea, and this was an idea that instead of, so think of it like this: if you so let's say you have to do spaghetti meatballs, right? Well, to make a meatball, there's a simple recipe for making a single meatball, but you have to repeat that several times, don't you? One for each meatball, effectively, and then put that in the spaghetti. So rather than writing out the instructions 10 times for making 10 meatballs,
so instead of having a list of instructions for spaghetti meatballs, which involves make one meatball this way, and then make one meatball this way, and then make one meatball this way,
which is the way you would have to do it normally. What most people recognize, you wouldn't do that. You just write the instructions once and you just say repeat those instructions 10 times, right? And you could do that with a loop, but not in the case of where you have to do steps and you have to come back to it later and do it again. So the idea of a subroutine is a set of instructions that we're going to call from all different kind of places and repeat them. And the complexity is it's slightly more complex than just branching, because you could always just jump somewhere and do that and then jump back, but it's that jump back that's the hard bit.
Because you don't know where you're going to jump back to.
Yeah, because if you're following a set of instructions, if our listeners imagine following a set of instructions and they get to a certain point, then they jump to the subroutine, they follow the instructions, then they jump back to where they came from, that's okay. But then if they do some more instructions and jump to that subroutine and then follow that set of instructions, they don't want to jump back to the first place, they want to jump back to the second place they were called from.
So if you imagine you're writing instructions in a book, and you're reading through instructions, it says turn to page 360, follow the instructions there. They write the instructions on page 360, it says go back to page 200 where you read it from, and then on page 250 it says go to that page again. This time you're going to go back to the wrong place.
Exactly. You're going to end up in a loop, actually. And that's not what you actually want to happen. So what you would write in that book scenario is you write go back to where you came from. So you need this concept for procedure or subroutine to run. They need to know where to go back to. And there's a slight bit more complexity than that, which is what happens in recursive procedures as well, and subroutines. This is where a subroutine calls something that ultimately calls itself.
So you just keep going in the loop forever.
And that actually can be quite a powerful tool.
It can also be very dangerous. So what the solution to this is we have a stack of where you need to go back to.
Okay. In simple terms, we say, okay, before you jump, create a put on this stack, and a stack is like think of a stack of books where you put a book down, then you put another book down, you put another book down, and another book down
on top of one another.
And we call this a last on first off. Right. So last in first out. So LIFO. So we take the last book that we put into the stack. And
the top book.
So when we take something off the stack, we always take the top of the stack. You can't take a book from the middle of the stack or a book from the bottom because you've got all the books on top of them. So you have to always take off the top of the stack. So the last thing you put in is the first thing you take off. And so in a stack, what we do is we have this stack of where do I need to go back to? Okay, and when you finish your subroutine, you pull the top item of the stack to know where to go back to. And you jump to that point. Now that's called an indirect branch. And that's the last innovation we need, which I think I alluded to on the last podcast, but I can't remember if I put that in.
So getting back to as if you're writing instructions in a book, it gets a bit tedious by hand, but what you would do is when you get called to go to page 360...
Say, make a note of where you are. Okay, so
write it down somewhere.
Or put it in a bookmark or something. And then at the end of the subroutine, you say, go back to where you said...
Go back to the bookmark.
Go back to the bookmark. So there's a good way of thinking of it. And of course, if you... In more accurate terms, you'd have many bookmarks and you'd number them, and you say go to the highest number bookmark, and that way it's like a stack. So you can think of it like that, and that's what a procedure is doing. It's adding on. The beauty is that stack, by the way, doesn't just have to have return addresses. It doesn't have to just say where you need to go back to. It can also hold local data, local scope, as we call it. And this is where things like arguments and parameters come in, and they're held on this stack. So this very same stack allows us to hold data that's only available and can only be seen by that subroutine.
Yeah.
And that's a huge part. That's the first level of encapsulation, which is a key concept in programming as well, which is this idea that you don't want the whole of your program to be able to access all of your data. You only want to have the bit of the program that needs to access the data to access the data, and that helps reduce bugs and problems. Until this point, everything's held in what we call the global scope, so somewhere where everyone can get it. Think of it like being out in public.
Yeah.
But now you can think of your procedural programming stack as being almost like a hotel with many floors, and every floor has its own context. And as you go up the hotel, you can only see the stuff in that floor. You can't see the stuff in the floor below you or any of the stuff in the floor above you. And that's a bit like what programming is. And by having that encapsulation there, encapsulation just basically saying only being able to see one thing at a time. By having that encapsulation there, you can help prevent other bits of code accidentally or deliberately corrupting the information that you rely on. And so procedural programming gives us those two really big fundamentals of computer programming, and it's probably the most revolutionary part of programming in the history of programming, in that it gave us the first element of real encapsulation, so what we call scope. We have local scope for the first time, and it gave us the first time of code reuse, where we could really effectively use code over and over again in different contexts at different points in our program execution. So much as I like to say cheery, we do have another bit of annoying news. Do you remember Articles 11 and 13?
No!
Yeah, I'm sorry, that's how I feel about it as well. Despite the initial hope, like I said, the fight was not over, and the European Parliament passed it yesterday, I think it was, with apparently amendments. So this is now going to go into January for the next phase of it, but it's back on the agenda and been passed through. I still think this is absolutely huge disaster for internet freedom and what we're trying to do. So definitely talk to your MEPs and send letters, get annoyed. This isn't the way that the world needs to be heading in terms of just protectionism for the people, the rich and powerful that have already got all these copyright, often illegitimate copyright claims. It's a bit sad, but hopefully this will still be defeated come January. Something tells me it won't, but we'll have to see. So the link tax, effectively, if you remember, was this would require Google to pay an amount of money to a site if it put an abstract of that site on its search results and took any of the articles or any of the statements out. So
this one where you put a link in an article, you've got to pay. You got to pay the place you're linking to. Now they've now said that if it's just a link, then you don't have to pay. But if it has an abstract or anything around it, so if it takes any content out of that article to promote it, then you'd have to pay. So, it's kind of bizarre, really, because it's basically saying, well, okay, you don't have to, don't promote us then. And I think this has been tried in Germany, and all that Google did was to stop listing those sites. And then the German sites effectively went back to Google and signed license deals with them to give them a license to use it for free. So it's stupid. And I think the danger is that that's what will happen with things like Google, and this will hit really small providers and be very anti-competitive in the long run, because I think most companies and stuff would just go to Google and opt in to an option to allow you to have that content, but you wouldn't do that in, for example, DuckDuckGo or one of the other search engine competitors and things like that. Why bother? Or Yahoo search or Bing, Microsoft's version. People are it's going to be very anti-competitive in that way. So it's the usual complete idiocy and lack of understanding from lawmakers and vested interests, I think, controlling a lot of politics these days, a lot of corruption, and a lot of large corporations funneling money into the pockets of these politicians we're seeing. So hopefully it'll still get defeated, but feeling a bit down about it, to be honest. What happens on social media? What if you share a link on social media and then it gives you the preview?
Yeah, I mean, I think, it's one of those other things, a bit like GDPR, which was also a wonderful piece of European legislation, not at all sarcastic, where sometimes the vagueness of it causes just a huge amount of space for people to snake oil salesmen, basically, to get rich out of consultancy and giving bad advice. And I think we're going to see the same kind of thing happen when these stupid new rules are adopted next year. We're going to see a lot of companies just scrabbling to figure out what it means. A lot of money wasted. A lot of bad impact on particularly European companies. And really, I don't think it's positive at all for... I mean, there's some ridiculous stuff. I read articles basically saying that, lawmakers were promised, Paul McCartney would give free concerts if the law was passed and stuff like this. There's all kinds of stupid stuff going on. Ultimately, these decisions...
You also see Paul McCartney anyway.
Yeah, these decisions should be regulated by people who actually understand what they're talking about, and that's not really what's occurred again. And I think this is one of the issues that we need to really get politicians. We need younger people to get involved in politics. We need younger people to go and get involved in parliaments and to vote, and the people that actually understand how the internet works, and to replace some of these vested interests and people that are just trying to hold on to the old way of doing things, and let us just innovate a little bit more and be a little bit more free to make a difference and to do stuff that's going to help all of us enjoy the world a little bit more. Well, that was episode 16 of the DevDecoder podcast. I think we got quite political.
And
unintentionally.
Some fun facts.
I'm not definitely some I'm not even sure the facts. We can never be too sure, can we?
Fun facts.
Yeah, okay. Although we had a good conversation with Jack again.
Always
a good conversation. Mm-hmm. Hopefully we haven't put people off from watching next week.
Why are you looking at me while you say that?
Can't think. Anyway, if you'd like to subscribe, remember to like, comment or subscribe, or to follow us on all the major social media platforms at DevDecoder.